Question: in a helicopter ride, the pilot first flies 12 kilometers north, then 14 meters north, 22 degrees toward east, and then 11 kilometers east. Determine the total displacement. This is the direction. This is north, also positive y. This is south, also negative y. This is east, also positive x. And this is west, also negative x. Now for vector delta d1, this is 12 kilometers north. So this is just vector delta d1. So from the graph, we can know that the vector delta d1y just equals vector delta d1 and equals 12 kilometers. It's positive because its direction is north, the positive y. For vector delta d2, this is 14 kilometers. The north, 22 degrees toward east. I draw the graph. This direction is east, also positive x direction. And this direction is north, also positive y direction. And the direction of delta d2 is north, 22 degrees toward east. So it should be here. This is vector delta d2. This is vector delta d2y. And this is vector delta d2x. This angle is 22 degrees. From the graph, we can know that the magnitude of delta d2x just equals the magnitude of delta d2 multiplied sine 22 degrees. And this equals 14 multiplied sine 22 degrees. And this equals 5.24 kilometers. So delta d2x just equals 5.24 kilometers. It's positive because its direction is the positive x direction. Then the magnitude of delta d2y equals the magnitude of delta d2 multiply cosine 22 degrees. And this equals 14 multiply cosine 22 degrees. And this equals 12.98 kilometers. So vector delta d2y is just 12.98 kilometers. It's positive because its direction is the positive y direction. Then for vector delta d3, this is 11 kilometers east. So this is just the vector delta D3. And this direction is also east, also positive x direction. So from the graph, we can know that the vector delta D3x just equals the vector delta D3 and equals 11 kilometers. It's positive because its direction is the positive x direction. Then at last, we can get the vector delta dx just equals delta d2x plus delta d3x and equals 5.24 plus 11 and equals 16.24 kilometers. And the vector delta dy just equals delta d1y plus delta d2y and equals 12 plus 5.98 and equals 24.98 kilometers. Then I draw the graph. So this is vector delta dx. This is vector delta dy. And this is vector delta d. And this angle is theta. This angle is a right angle. So from the graph, we can know that the magnitude of delta d, vector delta d, equals square root the magnitude of delta dx square plus the magnitude of delta dy square, and this equals square root 16.24 square plus 24.98 square, and this equals 29.79 kilometers. And the angle theta equals arctan theta, the magnitude of delta dy over the magnitude of delta dx. And this equals arctan theta. 24.98 over 16.24, and this equals 56.97 degree. Now we can get the total displacement delta D just is 29.79 kilometers. Then the direction is east, 56.97 degree toward north, because this direction is east and this direction is north.